What majestic languages in 33Q. Surely I'm going to learn how these ginormous cat-like cuties who have two mouths each communicate and win that cursed conlang circus. I never understood the Samiao languages of 33Q. According to the patterns in their speech and their almost telepathic if coalesced coordination, there is no way they aren't speaking a language, but about three things I'm absolutely positive. Hark. First, it was ruled by a Samiao leader named Repedak Juduxvizita and several others that I will not come back to this dimension. Second, there is a complexity in their technology and languages, and I don't know how impossible it may be for others, that my brain is too small to unravel. Third, I will instead submit the pigeon I created with the cats as a simplified form of the Samiao languages, a language which will still prove to be horribly cursed, while demonstrating how I unconditionally and irrevocably fear the languages it originated from. Welcome to the Geometric Simultaneous Meowing Pigeon, aka Gismepi. First, we'll start with the geometric part. Words and grammar are formed by shapes on a 2D Cartesian grid. Any shape that is drawn in a conversation or piece of writing stays there for the rest of that conversation or piece of writing. For example, the word for to move is a square, and the word for cat, and by that I mean the adorable giant cats in 33Q, is an equilateral triangle. Any square or equilateral triangle will have these meanings. A word only becomes a different word if you transform it so it's not similar to its pre-image, with some exceptions. This means the cat moves. The parts that indicate that cat is a subject and move is a verb are that one of the pairs of sides that intersect form a right angle, and they partition each other in ratios determined by their grammatical genders, which I'll talk about in a second. And the slope of the subject part of the pair, the cat, is vertical, while the intersecting side of the predicate part of the pair, to move, is horizontal. You could also have it so the absolute value of the slope of the intersecting side of the subject is greater than that of the predicate part, and that predicate can also be a noun or an adjective, which is how you would say to be since there's no copula. If the absolute values are the same, it may be ambiguous whether A is or does B, or B is or does A. But whether or not it's actually ambiguous is determined by their genders, over 600 of them, and they change to mark additional information. Take that! Okay, well, they don't have any actual ties to gender. At least, I don't think they have any ties to the cat's gender system. But they're not noun classes either, because verbs, adjectives, and adverbs have one too. So I'm going to call them ratios instead. So, a ratio has two components, a numerator and a denominator. There's 26 possible numerators and 26 possible denominators. The numerators are numbered in order as 1 through 26, and the denominators are the 26 letters in the alphabet in this order unique to Gismepi, which comes from this chart, which will also be used for pronunciation, writing, and proper nouns. I'm going to call it the letter chart. The values of the numerators are the same as their names, but the values of the denominators are the smallest prime numbers after 26, with the smallest assigned to H and the 26 smallest assigned to Z. Whenever I say that a side is partitioned in its ratio, I mean the side is partitioned in the ratio n to d minus n, where n is the value of the numerator of the shape with that side, and d is the value of its denominator. This square has the ratio 5u, and this triangle has the ratio 23d. The triangle partitions the side of the square in the ratio 5 to 56, and that side of the square partitions the side of the triangle in the ratio 23 to 49. But this is actually incorrect because you would almost never see these ratios used like this, because 5u and 23d are only their defaults, because as I mentioned, they change. For nouns, the change marks definiteness, number, and how much the speaker likes the noun. The three numbers are singular, pocal, which means few, and plural. And the 3 degrees of liking are that the speaker likes the noun, dislikes the noun, or is in the middle or has no opinion. For verbs, it marks aspect and mood/evidentiality. The 5 aspects are perfective, something happens; habitual, something happens often; perfect, something has happened; continuous non-eternal, something is happening but will end at some point; and eternal, something is and forever will be happening. The 6 types of mood/evidentiality are the subjunctive, which is for any statement that isn't true and often implies that you want it to be true. Assumptions or opinions are from an unknown source. Observations, having been told the information, having read about or overheard the information, and finally, obvious or self-evidential statements. Although I'm not entirely sure that that's what the last one is, because the cats kept saying some weird things in it. Adjectives and adverbs mark the same things as the nouns and verbs they modify, including when it's an adjective to a subject, like to be adjective, and they also mark degree of comparison, which means this chart is a lot bigger. Positive means it's not compared to anything. More and less are when you are comparing them, but not as superlatives, since those are most and least. There's also equal for when the comparison is that they're about the same, and mean for when it's average compared to everything else. You can also use the more, most, less, and least degrees of comparison for changing the intensity of adjectives and adverbs. For example, you could say the equivalent of more majestic to mean very majestic, and most majestic to mean extremely majestic. For adjectives and adverbs on adjectives, look at the yellow text, and for adverbs on verbs, look at the purple text. The numbers in these charts show how many shifts you make in the ratio. Shifts in the numerator are notated in the number on the left of the slash, and one shift means you change it to the next highest number, and wrap around to 1 if you go past 26. Shifts in the denominator are notated in the number on the right of the slash, and one shift means you change it to the next letter following this order. For example, 5u shifted by 16-2 is 21e, and 23d shifted by 7-0 brings you to 4d. So the actual ratios you would use for the cat moves are 21 to 50 for the square, and 4 to 69 for the triangle. In addition to verbs, if a noun or adjective is the predicate part of an intersection between subject and predicate, that is, to be noun or to be adjective, that noun or adjective is shifted for both its role as a noun or adjective and its role as a kind of verb, which can only have the continuous or eternal aspect. And each polygon has its own ratio. So compound words, which are made with multiple polygons, don't have just one ratio, because each root word that makes it up has its own, which is usually the same as its ratio when it's not in a compound word. The way polygons are combined in compound words is that they share sides, or at least have sides that intersect each other at infinitely many points. Going back to basic sentence structure, when you have a transitive verb, mark the direct object by making the verb share a vertex with the object, and also making one of its sides intersect the subject, partitioning each other in their ratios. To put an adjective on a noun, or an adverb on a verb or adjective, put it completely inside the word. If none of its sides are partitioned by anything, meaning its ratio is not revealed, you can do that with array whose endpoint is on the side that is partitioning. If you want multiple words with the same role in a sentence, like subject, verb, adjective, or object, just do the same thing you would normally for each word. To make the sentence a yes or no question, instead of making the side of the predicate partition the side of the subject, make it partition one of its angles in its ratio, and also make the mood subjunctive. If you don't do that, then that's how you indicate that the partitioning is a complete coincidence and does not matter. Pronouns. Scary, right? But don't worry, there's only an infinite number of them. This is the chart of all the pronouns. All of the pronouns. There's only personal pronouns. They have 3 persons and 3 levels of animacy. Feline is the highest, then non-feline animate, then inanimate. Referring to someone or something with the wrong animacy can be used as an insult. If you run out, restart at the beginning and add 1/2 to each number of degrees. And then if you run out of those, add 1/4 to the 1/2. And if you run out again, then add 1/8 to the 3/4. And then just keep adding the reciprocals of powers of 2. Why would you run out? Because every entity or group of entities you mention needs to be assigned its own separate pronoun, specifically the next highest number of degrees for the person and animacy you want. You assign a pronoun when you say the noun for the first time, by intersecting one of its vertices with a ray. Imagine starting this ray with a slope of 0, pointing to the left and rotating it clockwise about its endpoint by the number of degrees indicated by the chart. Once the pronoun is assigned, then you have to use it every time you mention the entity, by drawing a concave kite that pointing in the same direction like there's an invisible ray starting at point C and passing through point A. You can assign these pronouns to other pronouns if the person doesn't match. For example, if you assign yourself to a first-person pronoun, then the person you're talking to has to use that pronoun and assign it to a second-person pronoun with the corresponding ray. The ratio of these kites is the same as the ratio of the word it comes from if that word is not compound. And if it is a compound word, then the numerator is the average of the numerators of each root word, rounding up if it's fractional, and the same goes for the denominator, using their values as the 26 smallest prime numbers after 26, rounding up if it doesn't match one of the 26 values. And you start with the numerators and denominators after they're shifted, not the defaults. Alienable possession, or when something is possessed and could easily be removed from its possessor, is indicated by drawing a line segment with the slope of the pronoun that the possessor is assigned to, in a way that partitions the side of the shape and the line segment itself, in each other's ratios, without forming a right angle. If the angle of the pronoun is less than 180 degrees, make the main endpoint further from the side it's partitioning than the other endpoint, and if it's greater than or equal to 180 degrees, make the main endpoint closer. A line segment's main endpoint is the one with the greatest x value, and if there's a tie, the tiebreaker is which vertex has the greatest y value. If the possessor hasn't been assigned to a pronoun yet, assign it somewhere else. It's common to just put the noun with the ray assigning it to a pronoun in a random place not connected to anything else. For inalienable possession, which is when the thing being possessed can't be easily removed from its possessor, just make the noun or pronoun intersect what it's possessing so that the absolute value of the slope of the side that it's intersecting is greater than that of the side of what's being possessed, or make the side of the possessor completely vertical, and also make the pair of the intersecting sides partition each other in their ratios. This is a lot like with the subject and predicate, but the difference is that it doesn't form a right angle. Speaking of predicates, tense is marked by taking any word that's perpendicular to a subject and rotating one of its polygons about one of its main vertices, which is like a main endpoint, but for vertices. For the present, rotate it 0 degrees, so just don't rotate it. For the recent past, rotate the verb 90 degrees counterclockwise. For the near future, rotate it 90 degrees clockwise. For the distant past or future, rotate it 180 degrees. This rotation occurs after you draw everything else. And there's also a different tense you have to indicate. All predicates are ranked from first to last in chronological order, since the order you draw the shapes in doesn't indicate anything. The cats drew them in a completely random order. They jumped from drawing one sentence to drawing another, which was confusing to say the least. The way you rank predicates is by marking one shape from each one. The area of that shape compared to the areas of all other marked shapes indicates the predicate's rank. The predicate with the marked shape with the smallest area is first, and that with the largest area is last. To mark a shape, draw a circle whose center partitions one of its sides in its ratio, and if a clause only has one predicate, any polygon in that entire clause can be marked by the circle. It's common to use one of these marking circles to also assign a clause or multiple clauses to a pronoun, but you could also use a separate circle for it. To assign a clause to a pronoun, make a circle go entirely around the clause, and then draw a line with the correct slope that's tangential to the circle. It also matters what side of the circle it's on. Imagine starting at the top with a slope of 0, and rotating the line clockwise around the circle as you increase the number of degrees. The number of the pronoun matches the number of sentences being assigned to it, and the animacy, person, and ratio of the pronoun matches the subject out of any of the sentences that has the highest or one of the highest animacy. The pronoun is definite if the sentence does not have a subjunctive verb, and indefinite if it does. To make a proper noun, first write the name with the 26 letters in the English alphabet. Then, read it as a base 26 number, where the ones place is first and the highest place is last, using the letter chart with H as 1 and Z as 0. That number is the perimeter of the polygon you're going to draw. It can be any polygon, as long as you draw a line segment, or ray that partitions two sides of the shape in its ratio, and that ratio matches the first two letters of the name in the English alphabet, where the first letter is converted to a numerator according to the same chart with H as 1 and Z as 0. There are two polygons for talking about numbers, and those are a regular hexagon and a hexagon made by taking a regular hexagon and moving one of its vertices to the center of the hexagon. They behave like an adjective in that they go inside nouns to modify them, and you can use array to indicate their ratios. But they're also different in that the ratio indicates what number they represent, and while they still agree with the noun they're modifying, they can only have the positive degree of comparison, aka they're not being compared to anything. The value of a regular hexagon's numerator multiplied by the value of its denominator is the number that it represents. The value of the irregular hexagon's numerator alone is the value it represents, and its denominator is the same as the denominator of the noun after its ratio is shifted. You can intersect a hexagon with as many other hexagons as you like, partitioning each other in their ratios, and those partitioning intersections have to form right angles, and all of the hexagons intersecting add up to get the final number. To make a number ordinal, draw as few lines as possible that partitions every polygon that makes up the number. To make a number negative, reflect every polygon that makes it up about the y-axis. Now going back to the word move, I didn't entirely tell the truth when I said it was just a square, because it's also rotated and then reflected. That means most of the sentences I've shown are not correct, because I didn't transform that square or any of the shapes. These transformations are like additional phonemes, in that they only serve to distinguish root words from each other. This is what I meant when I said there were exceptions to the statement, a word only becomes a different word when you transform it so it's not similar to its preimage. Every non-compound word is either not transformed at all, only rotated, only reflected, or rotated and then reflected. When a word is rotated, that means you have to rotate it n degrees clockwise about its main vertex, where n is the sum of the numerator and the prime number value of the denominator after you shift them. When a word is reflected, that means you have to reflect it over the x-axis. This transformation happens after the whole sentence is made, as well as after you transform shapes for tense and negation, because negation is also indicated by a transformation, specifically reflecting over the x-axis. You can only negate heads of predicates, so that means verbs as well as nouns and adjectives that have an invisible to be. Now that I've described a significant portion of the grammar, the next part is how you pronounce and write it. We're going to use the letter chart again. Mouth A and mouth B are the two mouths of a cat. Mouth A is the one on top, which has a lower overall pitch, and mouth B is the one below it, which has a higher overall pitch. The mouth A phonemes are and the mouth B phonemes are. But these are just approximations from 11A cats. Their mouths are not the same, and I don't know how they're actually pronounced, beyond the fact that I'm pretty sure they're oral. A tail move means you move your tail from one side of your body to the other, so that's left to right or right to left. And a tail curl means you make your tail curled up if it's not, and uncurl it if it is. I've also made a romanization that looks like this. Each letter is pronounced with one mouth A phoneme and one mouth B phoneme at the same time. The letters are used to draw shapes one by one, and you can see the shapes in any order you want. First, use the first letter to say what kind of shape it is. E starts a circle, which takes the center point and then any point on the circumference. G starts a polygon or line segment, which takes each vertex or endpoint going either clockwise or counterclockwise. R starts a line, which takes any two distinct points on that line. And B starts a ray, which takes its endpoint and then any other point on the ray. Then, for each point of the shape that you need to draw, say its Cartesian coordinates. If you're speaking, you first say only the fractional parts of the x and y coordinates at the same time, by having mouth A hold a meow for n times 88 plus 1 turns, where n is the fractional part of the x coordinate, and having mouth B also hold a meow for n times 88 plus 1 turns, where n is the fractional part of the y coordinate. A turn is a common unit of time in 33Q, and it's approximately 1/25th of a second. This puts the amount of time in the range of almost 0 to about 3.5 seconds. You can also do multiple consecutive meows, so that the total time the mouth is meowing is n times 88 plus 1 turns. I can only go off rounded numbers since most coordinates used in Gismepi have infinitely many digits, and I'm pretty sure the cats are rounding the lengths too, but I don't know just how many places they round to. It seems almost infinitely precise? I don't know. But if you're writing, set the color of the x and y coordinates individually based on the fractional parts of the x and y coordinates. The wavelength to the color of each coordinate is approximately n times 60 plus 360 nanometers, where n is the fractional part of the coordinate. This makes everything purple or ultraviolet, which the cats can see. And in order to get a very precise wavelength, I had to use this weird pen thing the cats had created, which is kinda also like watercolor in that the colors blend into each other a bit, blurring the boundaries between letters, which is fun. Once you're done with the fractional parts, say the remaining integer parts. First is the x coordinate, which is in base 11, using the first 11 letters in just Meppi order. So h is 0 and e is 10. The ones place is last, and the highest place is first, like how numbers are written in English. Then you say the y coordinate, which is the same, except using the 11 letters after the first 11, meaning d is 0 and v is 10. Finally, after you've described every point needed for the shape, indicate its end with a string of j's, x's, q's, and or z's. For each point in the shape, add j to the end if both of its coordinates are positive, x if only its x coordinate is negative, q if only its y coordinate is negative, and z if both coordinates are negative. The color of both the first letter that tells you what kind of shape it is, and the string of j's, x's, q's, and or z's is decided by getting the area of the shape, or the length if it doesn't have an area, or the absolute value of the slope if it doesn't have a finite length, in Arabic numerals, then moving the decimal point before the first digit that's not 0, and then the wavelength is n times 60 plus 360 nanometers, where n is that number. Most of what I showed you was not my actual handwriting, because my friends keep telling me that I have such bad handwriting, which I ended up teaching the cats, that I need to put a key for how to write each letter for how Just Meppi is actually written. So here you go. They also asked me to tell you that once you're done writing one letter, you don't lift your writing utensil or move it at all from that spot. You just immediately start writing the next letter. And also that the J's, X's, Q's, and Z's have combined into ligatures in groups of 2 and 3, like this. And making a 3-letter ligature is preferred over making a 2-letter one. Even if I were allowed back in 33Q, I would not want to return, for I despise the pigeon forever curled in my heart and the 17 hearts of each cat.